The fate of the planets is intricately tied with that of the star that they orbit. So for our own solar system, the sun dictates our fate.
As our sun has changed, so has the potential for life on our neighboring planets. Their history shows that habitability is a delicate balance. That doesn't always last. There is only one planet that has retained its water and habitability, and that's Earth.
What's remarkable about Earth is the stability of those conditions, that Earth has been able to maintain oceanic conditions at its surface throughout its entire history, through billions of years, and that's what's facilitated the very rich biological evolution of Earth.
Earth is a very special place. It's the only place in the universe where we know definitively that there is life.
For that to happen, you need not just liquid water appearing on a planet, but liquid water staying on a planet, and that's the magic of Earth.
Thanks to the size and geology of our planet, the atmosphere has remained stable enough for billions of years, protecting the precious water that has enabled complex life to evolve. Life has woven itself into the fabric of the planet. And has shaped the continents and the oceans. So that now, life itself maintains the very atmosphere that protects our fragile ecosystems. But as the sun continues to grow hotter, temperatures on Earth rise. Upsetting weather patterns, raising great storms across the planet, and devastating droughts. As plants around the world die out, oxygen levels plummet. Around 1 billion years from now, the age of complex life on Earth will finally draw to a close.
Earth will ultimately be like Venus and Mars, just mostly CO2. There'll be nothing else really in the atmosphere. And it will remain in that state as sort of hot oven planet until ultimately the sun, when it uses up its hydrogen and goes into a different phase, will become what we call a red giant.
You know, as we've seen in other stars throughout our galaxy, throughout the universe, our sun will continue to get hotter and hotter over time.
And at that point, it will expand greatly to the point where it will nearly engulf the Earth entirely. And at that point, the planets will lose their atmospheres and they'll be just sort of swept away.
As it exhausts its hydrogen fuel, the sun's outer edge inflates. As our star enters its red giant phase, expanding millions of kilometers out into space. Mercury is the first to be engulfed. Then Venus's fate is sealed. Some models predict that Earth may barely escape the fiery fate of its neighbors, hanging on beyond the edge of the dying star with Mars. But the long era of the 4 terrestrial planets will be over. The lives lived on one of them, nothing more than a distant memory.
Poor Uranus. It's got rather boring clouds, truth be told. So there wasn't a lot to see with the cameras.
Passing close to the planet, Voyager's sensors reveal why Uranus is so featureless. Temperatures here are the coldest of any world in the solar system. There's simply not enough heat to drive the storms seen on Jupiter and Saturn. Uranus is an entirely new class of planet. An ice giant. And more surprises were to come. Uranus has rings.
We knew long ago from telescopic observations the rings were there at Uranus. We didn't know their configuration or their shape.
Voyager begins to explore the ring system and spots something curious in the shadows. Two moons, Cordelia on the inner edge of the brightest ring, and Ophelia on the outer edge, help to organize the system.
Particles within the rings can be moved inwards or outwards as these tiny objects called shepherd moons, whose gravitational force can shape and sculpt the rings themselves.
But it's the orientation of the orbits of these moons and the rings themselves that singles out Uranus as the strangest of worlds.
Uranus looks bizarre. The rings, rather than looking like that when you look through a telescope, they're actually orbiting up and over the top of the planet. The whole thing is tipped like a spinning top.
This bizarre orientation hints at an unusual past. Since the beginning, everything in the solar system has been circling in the same direction. It begins with a vast cloud of material that orbits the young sun. Over time, the material draws together, forming each of the planets. Today, they all orbit the sun and spin on their axes in the same counterclockwise direction as that primordial cloud. Except for Venus and Uranus, which spin in the opposite direction. But Uranus is even stranger. because the entire planet is on its side.
This was a really strange system. So why is Uranus so tipped on its side?
If a roughly Earth-sized object smashed into Uranus late in its formation history, then that would have had the proper amount of momentum to basically knock it on its side.
And the collision may also help to explain another of Uranus's mysteries: why the planet is so cold.
That impact presumably relinquished all of that internal energy that the planet had when it first formed, and has left it as a relatively dead and sluggish world.
Much is learned during this brief encounter. But Voyager's strangest discoveries are yet to come.
Is the signal real? If the signal is real, we still have to be able to explain what or who is making it. I've dedicated my entire career to finding life beyond our Earth, and lately I've been trying to find it on Venus, the planet next door.
Oh wow, life on Venus. That just blew me away.
Venus is an absolute hell. The temperatures on the surface average about 470 Celsius, which is hot enough to melt lead. Air pressure on the surface is what it would feel like to be about a mile under the ocean. Because the clouds of sulfuric acid are so dense with haze, Venus became a desolate hellscape. The Veneer missions were an extraordinary program. Several of the Veneers didn't even attempt to land. One of them lasted 127 minutes and provided a lot of data. Some tried to take pictures, but the lens caps wouldn't come out, and by the time we got to 7, 8, 9, 10, 11, 12 Veneer missions, we had managed to get to the surface of Venus, take measurements and be sure of its intense temperatures and pressures, and also the hurricane level winds that were passing in the atmosphere.
When they eventually got the correct sort of radar going through the clouds and seeing what was going on, and then it got really exciting. Then we thought, this is a planet with a lot of volcanoes on it, and even more fascinating, volcanoes unlike any we see on the Earth.
These volcanoes had been partly responsible for spewing out gases that led to Venus becoming the fiery hell it is now. But recent data shows there may still be life left in them yet.
They found that Venus had hotspots within it, something active on Venus. That really is quite exciting to actually see these.
We do know life is very resourceful, and there is one place on Venus that could host life. If there is alien life in the clouds of Venus or anywhere else beyond the Earth, we have very little hope of ever actually seeing them. But we can look for the gases that life produces, and that is what I've dedicated my entire career to do. My specialty is looking for a gas called phosphine. It was just here, you know? I was actually trying to find my phosphine molecule. Okay, well, we lost phosphine, which actually is very fitting. On Earth, phosphine, it's produced by life that doesn't care for oxygen. So I thought maybe we could find phosphine on other planets that are oxygen poor, and there it would be a very robust sign of life. An astronomer from Cardiff named Jane Greaves reached out to me saying,
Oh wow,
perhaps there really are these floating microbes.
They needed some help interpreting a potential signal from Venus obtained with the ALMA telescope that seemed to indicate there was a sign of phosphine in the clouds of Venus.
When you go really high up, so about 50 kilometers up, the pressure in the clouds is like it is at the surface of the Earth, and the temperature is actually like 20 or 30 centigrade, so it's really quite habitable.
Jane and the rest of our team used 2 telescopes, many months apart and in completely different parts of the world, to look at the atmosphere of Venus. And these 2 independent observations agreed with one another.
So that was January 2019 when I was reasonably sure, and that's June of 2019. I was like, here it is again.
I at first did not believe it, but there was a small part of me that thought my whole career had been for something.
It's really obvious there's something there, so that kind of blew me away.
Maybe all the work I had done saying that phosphine was a sign of life was just going to pay out right now.
Astronomers have announced they found what could be evidence of life elsewhere, and not on Mars, but on the much more inhospitable Venus.
There's something seriously weird going on there. Perhaps this is life. And that just blew me away. It was so exciting.
So you can see that really they look very like each other. So it was a robust result, 2 telescopes, nothing to do with each other, saw the same thing.
My second instinct that kicked in quite quickly was, is the signal real? If it is it for sure phosphine, or could there be another molecule mimicking it? And if it is real and it is phosphine, was I right in saying that only life could produce it?
Well, there are 2 ways that it could possibly be life. One is there's just a completely different biochemistry there. It's radically different from anything we imagine on Earth. The other way, that in principle, a more water-loving life, a bit more like the biochemistry you see on Earth, could hide itself away inside a protective shell of some sort, inside the sulfuric acid droplets.
There's questions on whether even the signal is real. If the signal is real, there are questions on whether it is phosphine or potentially other molecules that can mimic the same signal, like sulfur dioxide. If the signal is real and it is phosphine, we still have to be able to explain what or who is making it. And only then could we consider that we have found life. We're all just trying to figure out the truth. And I would love for there to be phosphine, but primarily I would love to know what's happening in the clouds of Venus, phosphine or no phosphine. And the rest of the community is doing the same thing.
Really hoping somebody will come in and say we could start to plan for a space mission. A fly through the atmosphere would be super exciting, and given they managed to get a lander to the surface and signals out in 1985, that's got to be possible, right?
We are only just now beginning to be able to even interpret the signals from places that could host life. It's a really exciting time to be discovering potentially the first one of those signs in the planet next door. But there will be many, many more to come.
The Milky Way could fit into the universe as we know it 10 million times. So it's big, really big. And we know that it's expanding at an exponential rate, which means that in about 1 billion years' time, the universe will be about 10% bigger. So do we know how big the universe is right now? And could we ever actually map out the size of the universe? So let's start with the bits of the universe that we can actually see. Light has a speed limit, so there's only so much of the universe that we can actually see, and we call it the observable universe. We think there are around about 170 billion galaxies in the entire observable universe. What we really need to work out how big the universe is a 3D map of it. That's what the Sloan Digital Sky Survey is trying to do. With 3 coordinates, you can make a 3D image of where to find all of the galaxies in the universe. By placing the plate with the galaxy coordinates over the telescope, they could isolate each galaxy individually and work out a 3rd coordinate for each one. That 3rd coordinate was redshift. And with redshift, the team could get the distance to each galaxy from the Milky Way. Dr. Slagle called it a 3D movie on a colossal scale. His team essentially brought the stuff of science fiction to life. Using this new map, cosmologists were able to see how galaxies were arranged in space.
Maybe you've seen things like this in the opening of Star Trek or Star Wars or whatever, and that all looks great, but it's not real. This movie, it is the real universe.
Just like our galaxy, the universe is held together by gravity, but there weren't enough galaxies to generate enough gravity to actually hold the universe together. Most of the stuff in the universe was missing. So this map led astronomers to some more evidence for something they'd been theorizing for quite a while now.
It's simply not enough stuff to arrange things into the patterns that we see, have galaxies spinning in the way that they do. There's something else there. There's something beyond the galaxies that we see, the visible matter.
It's called dark matter. It's invisible, and we haven't found a way of detecting it in a lab yet. I know it can seem like us astronomers just start making up wild theories when we don't understand maybe what's going on, but we do know dark matter is there, in the same way that we know the wind is there because we see the trees move. We have so much evidence for it, including the fact that the gravity it generates is literally holding the cosmos together.
What we're finding out there in the universe is really weird. It's equivalent to the idea that only 1 out of 6 cities in America actually has any people living in it.
There is 6 times more dark matter than there is in all of the stars and the dust in 170 billion galaxies in the entire observable universe. So does that mean that the universe is 6 times bigger? Well, no, not quite, but the universe is certainly 6 times heavier than we thought. And it's complicated by the fact that the universe isn't just full of invisible stuff that we can't see, but the stuff that we can see is also moving away from us. The universe is getting bigger, literally, as we sit here watching it.
It's an observational fact that if you look at the galaxies around us and the most distant galaxies that we can see, they all appear to be moving away from us. If you were standing in California, you would see New York moving away from you. But from the perspective of New York, you would see Boston move away.
By observing the brightness of supernova, Professor Saul Perlmutter and his team proved that the universe is not only expanding, but that its expansion is speeding up at an alarming rate.
At the end, we concluded that actually the universe really isn't slowing down. It's actually speeding up in its expansion. And that was a big shock.
Professor Perlmutter's discovery was so important to the scientific community that in 2012 he was awarded the Nobel Prize in Physics. So after you establish something like that, the question on everybody's minds is why?
Well, we don't know, but we did work out what to call it. We have a name for it. We call it dark energy.
We figured out that the universe is about 68% dark energy.
The really crucial thing about how this dark energy behaves is that it doesn't dilute. When the universe doubles in size, you got twice as much dark energy. Make it 4 times as big, you've just got 4 times as much dark energy.
So how do you measure something that's big, that's getting bigger, that's full of stuff that we can't see? Well, unsurprisingly, you can't, or at least we can't yet. But what we have done is map out the stuff that we can see. And as usual, the universe has done things that we never expected it to do. And that map revealed that the universe is flat. Cosmologists plotted 3 points of a very big triangle that went from Earth to 2 points in space-time as far back as we could go.
If the universe were positively curved, if the angles inside the triangle added up to greater than 180 degrees, then it would be finite in size. If the spatial geometry is flat, if the angles inside the triangle add up to 180, then it could go on forever.
The answer was mind-blowing. Space itself is flat. Now, we're not talking about the shape of space here. We don't mean space is flat like a piece of paper. We're talking about how light behaves in space. For it to be flat, it means that light would travel on in an infinite direction and never be disturbed. If space wasn't flat, that light could loop back on itself. It'd almost be like if you could stare out for long enough and detect light faint enough, then you would be able to see the back of your own head.
That means that the simplest picture of the universe is a universe that's infinite. We really could live in a universe where there's galaxy after galaxy after galaxy in every direction, up, down, sideways, and it never stops.
This provided the perfect picture of what the universe looks like. An infinite universe filled with galaxies in all directions that is still getting bigger. Absolutely mind-boggling. Black holes aren't what you think they are. They're not holes, they're not black, and we can actually see them. And we've even managed to take a picture of one. You are currently looking at something incredible. The first ever image of a black hole, the one at the center of the Messier 87 galaxy, 55 million light years away. Now we know there's a black hole at the center of our galaxy, the Milky Way, which is 27,000 light years from the solar system. And we know that it's super massive because in 2008, Professor Andrea Getz and her team measured how big it was and found that it was 4 million times more massive than the Sun. This measurement was such a big deal that in 2020, she won the Nobel Prize in Physics. To work this out, they studied the orbits of the stars moving at incredible speeds around the black hole and used this to weigh the black hole.
If there's a black hole at the center of our galaxy, that's going to force these objects that are really close to the black hole to move much faster than they would move if there were no black hole. So the first thing you want to see is that there are very fast-moving objects where you think the black hole is. If there's a black hole, there's a further prediction you can make about what these stars are going to do. They're going to move around the black hole on very short periods. In other words, you're going to be able to see them move on more than just straight lines. As part of their travel around the black hole, these stars are going to move around the black hole because of the gravity, just like planets move around the sun.
Contrary to their name and to common belief, not all black holes are black. In fact, the gas and dust that spirals around the black hole can be accelerated to huge speeds, which heats up due to friction, causing it to glow. In fact, feeding black holes are some of the brightest objects in the entire universe. There's a supermassive black hole in the center of every galaxy. So how do we know? When quasars were first discovered, they were thought to be hugely bright stars, and any ideas of them being black holes were dismissed as just crazy. But we now know they are feeding black holes. And they're described as feeding because stars and gas clouds that get too close are torn apart violently by the immense gravity and then lost beyond the event horizon to become part of the black hole. They're essentially like a little snack for the black hole. There's a quasar at the center of the Cygnus A galaxy that's 1 trillion times brighter than our sun. And Dr. Andy Fabian from the University of Cambridge is studying this quasar with X-ray images. These help reveal the gas clouds that are orbiting around the black hole.
There's a lot of other things going on out there, and enormous amounts of energy being released, which we can only be aware of if we look with X-ray eyes. We could see what was going on at the center, and we could start to understand how the black hole was feeding energy out into all the surrounding gas.
The friction generated by this dense atmosphere of gases produces the hottest and most electrically charged environment in the universe.
What we know is that the hotter something gets, the brighter it gets, the more light it emits.
By feeding on all this gas, the black holes sometimes end up with just too much material around them and end up burping out a load of it, which then impacts the galaxy. This can actually expel a load of the gas that the galaxy would have used to make more stars, and essentially stopping the galaxy from growing any bigger. So black holes seem to wield a worrying amount of power. They can literally control how big a galaxy can grow.
Galaxies could, in a way, be much bigger than they currently are. Something is stopping them growing larger, and that something is the black hole at the center. Now, this is bizarre because the ratio of the size of the black hole to the size of the galaxy is the same as the ratio between a grape, something this big, and the size of the Earth.
It sounds impossible that something that small would have so much control over something that big, but that is what's going on. It's been calculated that the mass of a black hole is on average about 0.5% of the mass of a galaxy. Essentially, the bigger the galaxy, the bigger the black hole will be. This correlation made astronomers start to wonder whether black holes might have been present or even responsible for the birth of their galaxy.
Because it really meant that there was something linking these tiny supermassive black holes in the center of galaxies with the whole galaxy itself. It meant that somehow their whole history had been intertwined, that the growth of the galaxies and the growth of the black holes was somehow related.
Now, in the early universe, we don't know if stars formed first or if black holes formed first. But if the black hole formed first, then the galaxy of stars could have then formed out of the gas that was swirling around it. What everyone really wants to know, though, is what happens when a star gets swallowed by a black hole. Well, a couple of years ago, a gas cloud called G2 came perilously close to the event horizon of the black hole at the center of our galaxy, the Milky Way.
This is the first time, really in human history, that we have not only known an event like this was going to happen, but that we are prepared with the right sort of technology to see the details unfold.
Astronomers monitoring the event were able to test the effects of the black hole on this gas cloud. It was essentially on a collision course with one of the most powerful entities in the entire universe, and it was being stretched out on its way there.
It was moving quite fast, and it's not moving in a straight line, but it's a curved line. And that's a very, very bad sign, because it tells you, well, there's something acting on it. It tells you, wow, gravity is pulling on that object.
Instead, though, it was spaghettified, and it circulated the black hole and then was essentially catapulted back out into space. Lucky escape for the gas cloud. This event confirmed that it is possible to get perilously close to a black hole and still escape. So, there's a black hole at the center of every galaxy, and they have the power to dominate everything around them. But they're not just giant hoovers sucking everything up around them. Stars, gas, dust, they're all happy to orbit them with no issues.
We're seeing the black hole at the center having a galaxy-wide effect on the surroundings.
So if they really do have a galaxy-wide stronghold, and the one at the center of the Milky Way has been there since its existence, that means that you, me, and all the stars that we can see have always, and are currently, right now, orbiting a supermassive black hole. Nearly everything we've sent into space is still there circling our planet. Huge amounts of abandoned old machinery just littering space. It really is a terrifying thought.
When you're going 17,000 miles an hour, it does not take a big piece of debris to ruin your day.
The energy would be more like a 50 caliber Browning machine gun sniper round.
Experts are now beginning to ask, have we trashed space forever? Over the last several years, orbits around Earth have become littered with satellites and old pieces of machinery. So how much junk is in space?
Space junk is all the stuff that we've launched into orbit that no longer serves a useful purpose. So it's satellites, it's rocket bodies, it's old gloves, basically litter that we've left in space.
Now, this isn't a trivial issue, because as we enter into a period of more rapid space expansion, from space tourism to companies putting more smaller satellites into space, it's now estimated that the number of pieces of space junk up there is over 130 million pieces that are orbiting the Earth, and that number is only growing. So space is being littered with these dangerous, uncrewed pieces of machinery flying through space at breakneck speeds. It's a lethal accident waiting to happen. So what happens when junk collides?
Copy, Al. You're on your way to the station. Houston, big loop. Bag, and I'm going around.
In 2009, NASA actually had to order an emergency evacuation of the International Space Station when they discovered a piece of space junk about the same size as a CD traveling towards them at 8 kilometers a second.
We got a call that we were having a red conjunction, and we're looking around, what the heck is a red conjunction, because we hadn't really trained for it. It was a little bit chaotic because this was the first time we had one of these.
Copy, Al. You're on your way to the station. Houston, big loop. Bag, and I'm going around ESG2.
It's either going to hit or it's not going to hit. And so worrying about it doesn't help you. All you have to do is just prepare everything that you need to prepare so that if it hits, then you're in the best possible configuration.
Now, thankfully, the ISS wasn't hit that time, but this is a genuine concern for NASA, ESA, and other space agencies, because if it was hit, the damage would be catastrophic.
It gets hit by something relatively small, penetrates, but because the pressure inside it just forces the modules to open up, just like a balloon bursting. And that happens extremely quickly, and with no chance that an astronaut in that module could ever get out.
In fact, you can recreate these kind of collisions in a lab, and it really reveals how dangerous they really are.
You see your screen flash up, and it's over. All that work is turned into this. So this piece of modern art here, you can see it's all splayed out. Now that's about 250 milligrams. So that's a little bit bigger than heavier than a ibuprofen pill. And the energy that would have on orbit at, say, 14 kilometers per second would be, well, the momentum would be about the same as a hot-loaded 357 Magnum. So that's a lot of momentum. And the energy would be more like a 50 caliber Browning machine gun sniper round.
A single one of these collisions can create thousands of these tiny lethal fragments that act like space bullets that ripple out into space, causing unimaginable damage as they go. In fact, some forecasts suggest that a major collision like this could happen once every 5 years.
We see thousands and thousands of near misses every single day as a result of all the junk that we put up there. You end up in the situation where it's basically a lottery in terms of whether or not your satellite is going to be hit.
And this wouldn't just cause issues up in space. With so much of our modern world dependent on satellites for things like navigation and the internet, communications, weather forecasting, it would cause absolute havoc down here on Earth as well. Now, with more and more of these objects being blasted into space every single year, it's becoming a serious threat to modern life. So what can we do about it, and how will we solve this problem? Step one is actually tracking all of this space junk, and that's something that the US Air Force has been doing for decades.
Pre-pass SVN 26.
No time-critical commanding, no satellite conjunction, good on step 6.
They've been cataloguing space junk since the early 80s. They started with 6,000 and have grown to 10,000 over the next 2 decades. And since 2009, the amount of trackable space junk has gone up by 20% to over 25,000 pieces. But the problem is, the only space junk that's trackable is stuff larger than a cricket ball, and it misses those tiny, tiny fragments that can be incredibly lethal. So space agencies across the globe are working round the clock to come up with solutions to remove this space junk. One option? To use a space harpoon.
This system will capture those items of debris, tow them out of the orbits where they might collide with active satellites, and allow them to burn up safely in the atmosphere. So the idea is to have a system which takes them away from where they cause a problem and basically destroy them safely.
It's a great idea, but the thing is, it's a bit of a slow tactic because you have to remove everything piece by piece. And the problem is we're putting even more space junk up there just to do this. Now, other plans include capturing them in a net, or sticking a magnetic thruster onto them, or even using solar radiation to sail them off into the sunset. It just shows, though, with so many of these ideas being developed, how dangerous of an issue this actually is. And if our quest to remove this junk fails, and with the increase in objects littering space every single day, the question is, have we ruined space forever?
I want my kids and my kids' kids to be able to explore space. And if we ruin the environment, we can't do that. And that would be tragic, because my passion for space came when I was 10 years old and I watched Apollo 11 and I watched Neil Armstrong walk on the moon. And that magic that created that feeling in me that said, I want to do space. I want my kids and my kids' kids to have that opportunity. And if the space environment is ruined, that will never happen.
So just like we've seen laws come in to protect our environment here on Earth, we could also see laws come in to help protect space and the environment around Earth, with the hope of preserving the wonder and the beauty of the night sky for generations to come. Now, aliens contacting us might seem like science fiction, but now new mysterious signals from outer space are intriguing scientists around the world.
This signal was so bright that it was completely unlike anything we'd ever seen before.
It's not crazy to think that radio bursts could be created on another planet.
What causes them is one of the biggest mysteries in physics. So are these signals from aliens? Now, linking strange signals from space with aliens sounds a bit like something cooked up by conspiracy theorists. So is this real science? Yes, this is real science. It's the job of an astrobiologist to figure out where in the universe is habitable and if possibly intelligent life could have developed there and then contacted us. In fact, in 1961, pioneering astronomer Frank Drake organized a now infamous secret meeting to try and figure out how many civilizations like this exist outside of our own.
So we start out with the rate of star formation. Multiply that by the fraction of stars which actually have planets, habitable planets in each system, the fraction on which life develops, the fraction by which intelligence appears, by the fraction of those which actually give a detectable technology. This rate times the average time that these civilizations remain detectable. N equals about 10,000 detectable civilizations at present in our galaxy, the Milky Way.
Calling themselves the Order of the Dolphin, this group of award-winning scientists set out on the hunt for this huge number of civilizations that they thought could be out there.
Oh, I believe very strongly that they are out there. We can be very, very wrong, and yet there will be many, many detectable civilizations.
From secret government agencies to Nobel Prize-winning scientists, the search was on for weird, unexplained signals. First, there was the WOW signal in 1977, detected by the Big Ear radio telescope in Ohio.
The signal was strong, about 72 seconds, but more importantly, it was detected in something known as the hydrogen line. That was significant because at the time, astronomers thought that if extraterrestrials did exist, they would use that frequency. The astronomer Jerry Emmon was so excited that he actually wrote the term WOW on the printout.
But very quickly it was dismissed by astronomers as actually coming from a comet. Then in 2007 came a detection of what would become the biggest mystery in physics, something that could have been a game changer in the search for aliens.
My student showed me this signal that was so bright and apparently so far away that it was completely unlike anything we'd ever seen before.
Then we realized this is just impossible, unless a civilization is way more advanced than we are.
Scientist Duncan Lorimer and his team had found what we now call fast radio bursts. They're incredibly bright radio signals, so bright that they can't be coming from any naturally occurring phenomena on Earth. They have to be coming from outer space.
Quite frankly, it was unlike anything I'd ever seen before, yet it had all the hallmarks of a signal that was coming from deep space.
I did think that it could be a signal from an extraterrestrial civilization, We create signals like that on Earth, so it's not crazy to think that radio bursts could be created on another planet.
So it was a groundbreaking time for physicists, and with this new data from Lorimer, the burning question everyone still had was, are these alien signals? Now the problem with the Lorimer burst was that it was just a one-off, and how do you prove a one-off is real and not just some noise or some random signal in your detector? Well, it helped when other scientists around the world started detecting signals just like it.
They were coming from all over the sky, and they were clearly real, so it was a breakthrough moment.
Now, although this seemed really exciting, it meant that there were probably much more likely explanations for what was going on.
We observe binary systems of 2 neutron stars that are in orbit around each other, and when we observe these systems, we see them getting closer and closer together all the time. So what will happen eventually is that they're going to collide. And when they merge, the neutron stars will be completely destroyed and form a black hole. When you look at the energetics of these events, you can easily explain the FRB energies with them. You can also explain the durations of the FRB pulses with the expected durations of these merger events. So it's quite a plausible explanation.
Now, neutron stars are some of the most energetic objects in the universe, second only to black holes, and you need something really energetic to produce a fast radio burst. Now, astronomers recently have discovered a fast radio burst coming from a magnetar in our own Milky Way galaxy. A magnetar is a special type of neutron star that has a very high magnetic field. And while this is really exciting that we finally might have an explanation, it means that aliens producing FRBs is becoming a lot less likely.
Now that fast radio bursts are real, it comes back to the point whether they could be caused by aliens. So if I were looking for a signal from an extraterrestrial civilization, I'd be looking for it coming from a single point in the sky. Here we have a population of sources all over the sky, which implies that the aliens are all over the place, all over the universe. That just seems highly unlikely to me.
So we're one step closer to solving the mystery of fast radio bursts, even though it's looking likely that they're not the alien signals that everyone was secretly hoping for. But as a scientist, I reckon never say never. We'll always keep observing the sky, and I think in our lifetimes, we've got a great chance of discovering alien life somewhere out there in the universe.
We have done a great deal of searching in the last 50 plus years, and we've learned that we're going to have to search perhaps 1 million stars and countless frequency channels before we have a good chance of success. If I had this to do all over, I would still do it. I'd in fact probably put more time into it because I've come to realize that's what's required to succeed. And to me, that time is not time wasted because the eventual discovery is of such importance that it justifies not just one human life being dedicated to succeeding, but many.
We're guaranteed to find an identical copy of our whole universe, as well as countless variations where things are similar to here, but still different.
Multiple universes now are a genuine possibility, which begs the question, is there another you in a parallel universe? Now, it probably doesn't surprise you that studying parallel universes was once considered completely bonkers in the scientific world, and it even alienated people who decided to pursue it.
When I was a grad student, I used to secretly print out my multiverse-related papers.
This job was the only job I was ever interviewed for. I was on the verge of having to drive a taxi cab.
Now theoretical physicists have realized that parallel universes are possible, mathematically at least. So why do we think other universes exist? Now, one of these reasons comes from the weird world of quantum physics.
The important thing to remember about quantum mechanics is that it's weird.
It really is weird. It's the study of subatomic particles, the building blocks for every single thing around us in the universe. And what it tells us is that these particles can be both particles and waves, but crucially, they can be both at the same time, which splits our reality, giving us multiple different universes.
The idea here is that when you make a measurement of a particle that's here and there at the same time, and you find the particle over here, then there's a you which finds a particle over here in this world, but at the same time, there's another world over there where another you has found the particle over there. And both of these worlds are equally real. So the quantum multiverse is not separated from us by distance. It's not someplace very, very far away. It's someplace that's effectively here in space, but the complexity of the quantum dynamics prevents these different branches from talking to each other. Whether you like it or not, the fact that we live in a multiverse is the dominant scientific paradigm. Suck it up.
Another theory is one of mathematical inevitability. If our universe is made from a finite amount of simple matter, then it follows that other universes are made in a very similar way.
Just as this house is made out of fundamental building blocks that we call Legos, everything in our world is made of fundamental building blocks we call elementary particles. And if you have some random process arranging elementary building blocks in a finite volume, there are of course very, very many different ways in which it could do this. And that means that if this process repeats in an infinite number of other volumes of the same size, then we're guaranteed that eventually it's going to create every possible arrangement. We're guaranteed to find an identical copy of our whole universe, as well as countless variations where things are similar to here, but still different. Even a Max over there who's identical to me, not just in his physical appearance, but in that he actually feels that he is me.
Another theory called inflation describes how the universe expanded exponentially in the very first tiny fraction of a second after the Big Bang, but with some areas of space expanding faster than others, creating bubbles or pockets of space-time where other universes could have formed. If this idea turns out to be right, then it could mean that these pocket universes developed with their very own laws of physics. So there could be another you in those universes that's able to walk through walls or fly through space. So if our universe is not alone, the question remains, what would the other you be like? Well, according to quantum theory, there's a new version of you and a brand new universe made with every single decision you make.
So every time I flip a coin, say heads or tails, that is just some little quantum accident. The universe is splitting into two worlds every time it comes up heads or tails. So our experience of this splitting is like the experience of walking through a garden of paths that fork. When we come to a fork in the path, we take one or the other, heads or tails. But both forks exist at the same time. We only experience one of them. There are literally gajillions of universes out there, of which ours is only one.
Then there's the patchwork model, a near identical copy of our own universe, just made elsewhere. In this kind of parallel universe, there's another you that's very similar, just with subtle differences.
We're guaranteed to find countless variations where things are similar to here, but still different. The dinosaur killing asteroid that was our lucky break missed Earth, so there are no humans, just dinosaurs in Winchester today. There's another one where I didn't make it as a physicist, but I'm actually enjoying life working as a bartender. Then there's a whole bunch which are very similar where I just chose to dress a little bit differently.
These ideas all point towards multiple weird and wonderful universes existing out there. But with scientists not able to see the entirety of our own universe, how on earth can we prove that these other universes exist? Scientists think that they might be getting a little bit closer.
Truth goes through 3 stages. First it's ridiculed, then opposed strongly, and finally it becomes self-evident. Perhaps now we are reaching the stage of self-evident.
Scientist Laura Massini-Horton found something really weird. She found evidence for what appeared to be 2 universes crossing over.
The detection of the cold spot was one of the signatures that we predicted by tracing forward the quantum entanglement of our universe with all the other surviving universes. We predicted that there should be a large area in the sky of about 10 degrees, and indeed that's what was observed about 7 months after we made the prediction.
Recently, there's also been a big leap forward for inflation theory, which predicted that if this rapid expansion of the universe happened, it would send ripples out into the universe. We call these ripples gravitational waves. We'd never detected anything like this until 2015, when 2 experiments called LIGO and Virgo managed to detect gravitational waves coming from the merger of 2 black holes. With that detection made, it makes it more likely that we might be able to detect gravitational waves from inflation. But why should we really even care about figuring out if multiple universes exist? Well, it actually feeds into the age-old question of what is our universe expanding into? If other multiple universes exist, perhaps our universe expands as neighboring ones contract. And this could actually tell us more about our own universe, and especially how our own universe will end. Perhaps eventually we will expand until those other neighboring universes also then have a big bang and start expanding into us, which means that we then start contracting. And perhaps our universe will end not in a big bang, but in a big crunch. The universe is not what you think it is. That's because what you can see is only a tiny fraction of it.
We have no idea what 95% of the universe is. It hardly seems that we understand everything.
Maybe we're just going to have to scratch our heads and start all over again.
It begs the question, why is 95% of the universe missing? For decades, physicists have been trying to find this elusive, undetected part of our universe. And in the beginning, we just had a name for it, dark matter. So what is dark matter?
Sounds exotic, but it doesn't have to be. There's a lot of dark things out there in the universe. Until I shine my light at these bottles, I can't see them. Dark matter could just be ordinary stuff that you can't see.
Now, what we do know about dark matter is that it's matter that doesn't interact with light, so we can't see it. But we know it's there because of its effects due to gravity, because of the way that stars orbit the centers of galaxies. The stars on the edge move a lot faster than they should, so there has to be more matter out there on the outskirts.
Well, there's an alternative idea for what the dark matter could be. And so what we think it is that it's some new kind of fundamental particle. Not neutrons, not protons, not ordinary atomic stuff, but something entirely new. And these particles are everywhere in the universe. They're flying around in our galaxy. They're in this room. Actually, there'd be billions going through you every second. You don't notice, but they're there.
So this invisible matter that dictates how our universe works is known by particle physicists as WIMPs, weakly interacting massive particles. If we can't see them, how do we find them? Part of the problem is that here on Earth, we're searching through a relative swamp of ordinary matter that we can see, which kind of blocks our view of the stuff that we can't see.
If you were to try to build one of these experiments in a laboratory on the surface of the Earth, then your signal would be completely swamped by cosmic rays. They would just ruin your attempt to do the experiment because the count rate from the cosmic rays would be so high that you'd never be able to see the WIMPs.
And that's why scientists are doing something that at first might seem pretty strange. They're going underground and searching in the dark.
After walking a mile underground like this, you have to wonder about the fact that we may be looking in the wrong place. This is the inner vessel of Pico 2L, we call this project, and it goes inside that big recompression chamber. We put a liquid in there, what we call a superheated liquid. It makes it sensitive to radiation. So when particles strike the liquid that goes in there normally, it's now empty, they produce bubbles. Piezoelectric sensors, they're very sophisticated microphones, and through sound we're actually able to differentiate between different types of particles as well.
What sound would dark matter make?
It's actually very soft, it's not the loudest.
But of course there's a chance that looking for dark matter in this way, by essentially listening to it to see if it makes an appearance, might never be possible.
You do your job the best you can and then you hope for the best, but nobody knows if there's WIMPs out there or not. We're trying.
Now, other scientists are searching for this mysterious dark matter by using the world's largest physics experiment at CERN in Switzerland, the Large Hadron Collider. They're not listening out for it, they're attempting to make some from scratch. What they're doing is smashing together known particles at huge speeds to create huge energies in these impacts that might just spew off some particles of dark matter.
When the protons collide, most of the time the particles they produce, nearly always some new particles are created, but they tend to be low mass particles. But sometimes, very rarely, you produce these much more massive particles, and these are the guys that we're really looking for.
So the search for dark matter continues in underground labs and at CERN, and also by observing the night sky. And scientists believe they're getting closer to discovering what it's made of. But will we ever find it?
You have to accept the evidence. And if it turns out that I wasted my life working on the wrong hypothesis, so be it. What I really want to know is, what is the universe made of?
I can really see it as being a particle in nature, and I'm really driven, as we all are driven here, to try and find it.
And if you don't?
We will dust ourselves off and move on.
Whatever they do find will surely change the laws of physics as we know them. With scientists pushing new technologies and the boundaries of our knowledge, what's more, we've now realized that dark matter is only just the start of the story.
So 15 years ago, some astronomers observing distant supernova saw that the distance to those supernovae was larger than they expected. And so the only way that they could understand that was to have a universe that started accelerating 3 billion years ago. And whether that carries on accelerating or not, we don't know. But what we do know is that there has to be another component to the universe, which we call this dark energy.
But you don't know what it is?
No idea. Not at all.
No one knows what it is?
No one. No one. There are more theories than there are theoreticians.
So whilst dark matter might make up 25% of the unknown stuff in the universe, there's this whole other whopping 70% made up of something called dark energy. We know even less about dark energy. It's so weird and so unknown to us that we're actually going to need a whole other video to find out about it. 70% of our universe is made up of something so weird and so strange, it continues to baffle the world's brightest minds.
We are absolutely still lacking great ideas.
It is crying out for some new breakthrough, new thinking.
Perhaps the greatest remaining mystery in our universe. What is dark energy?
Dark energy is basically our name for that thing that we don't understand.
It's not the color dark, it's just an expression of our ignorance as to what is this stuff.
Genius could come up with a new theory. Yeah, it is quite possible. I'm kind of hoping it's me.
So this is clearly a huge deal in physics and raises many, many questions. The obvious one to start with is, why do we think dark energy exists? Now, ever since the Big Bang, our universe has been expanding, with space itself stretching, moving galaxies further apart. Now, physicists used to think that the energy that was made in the Big Bang to power that expansion would eventually start to run out and the expansion would start to slow down. Then, a Nobel Prize-winning discovery turned all of that on its head. Saul Perlmutter and his team measured the way the universe was expanding by comparing the brightness of supernova. This is when a star runs out of fuel at the end of its life.
They brighten as a firework and fade away, and they reach the same brightness. And you can then use that as an indicator of how far away it is by just looking to see how bright it appears to you. Just like when you watch a car recede into the distance, you can tell how far away it is by how faint the taillights look. If you can use the brightness of the supernova to tell you how far away it is, that's really telling you how long ago the explosion occurred, because you know how long it takes for light to travel that great distance.
And what they discovered definitely shook the physics world.
Suddenly, he was saying that we lived in a universe that was accelerating. I remember it just being incredible. I mean, all the astronomers walking around, scratching their heads, saying, this can't be right, surely it can't be right.
Now, exciting as this finding was, like many things in science, it raised a lot more questions than answers.
Once you know that the universe is actually speeding up, then you're faced with the question of, well, what could make it speed up?
This mysterious thing that was causing this newly spotted phenomena that no one could explain was immediately called dark energy. Now, it's great to have a name for this, but it doesn't exactly explain what is driving this accelerated expansion. So what is this energy? Now, just like with dark matter, which makes up 25% of the universe and is also currently unexplained, this weird type of energy seems to defy our laws of physics and has properties that our current models just cannot explain.
So you can think of it as you get more space, you actually get more dark energy, which is like getting something for nothing, which is clearly ridiculous. The way we think about it is that it's either some new stuff in the universe, some particle, or even just a new field that you put into the universe to explain the properties of the universe.
So what is it that's changing the way our universe evolves? Well, scientists differ in their thoughts of what it could be, from a liquid or a brand new particle like dark matter, or even an unknown force. Now, scientists at Berkeley in California are looking for something that they call chameleon particles. This is a whole new type of particle that's thought to create a force, which when it interacts with other particles, changes those particles' mass. By putting atoms in a vacuum, they're hoping to expose these chameleons.
The experiment works by first collecting a cloud of cesium atoms on top of the spheres, and the atoms are free to fall, subject only to the Earth's gravity and the potential chameleon force. We will either discover the particle or rule it out once and for all.
So far, they haven't found any evidence for these chameleon particles and their elusive force, but it is an idea that continues to be explored. So whatever this energy is, we now know that it makes up a whopping 70% of our universe. So how can we figure out what it is? Now, the obvious place to start is by looking at how the universe formed and has evolved with incredibly powerful telescopes.
One of the things that I do is try to simulate the entire universe and tie what we think about the physics of the evolving universe to what we actually see with surveys like DESI.
DESI, the Dark Energy Spectroscopic Instrument, is one of these incredibly powerful telescopes observing the distant universe. Now, the further away galaxies are, the younger they appear to us. That's because light takes time to travel to us. It can take even 1 billion years to reach us here on Earth. Thanks to this, we can look at the average distance between galaxies at different cosmic times and look how it's changed due to the expansion of the universe, and therefore figure out what is the role of dark energy. And what we need to do that is more detail, and we get more detail from more data. Now, there's a lot of projects and telescopes that are mapping the universe in this way, but one that we're all very excited for is the launch of the space telescope Euclid in 2022. It's the most powerful telescope ever created, even dwarfing the iconic Hubble Space Telescope. So it could be just what we need to solve this problem.
These are going to be the biggest images that come down from in orbit. You have an image effectively of 625 megapixels. So that's roughly 300 HD television screens full of data, and that comes down every 10 minutes. This imager takes roughly the same amount of data that Hubble has taken and will take in its entire lifetime in one day.
The hope with Euclid is that it will be able to give us the detail that we so desperately need to be able to solve this problem.
We have like lots of theories and hundreds of models that could still fit our data. When Euclid comes, lots of these can be thrown away, and it could narrow down the possibilities of what this dark energy is.
Euclid will give us a coherent data set that we can test all these theories against.
So dark energy remains the biggest mystery in physics, but with all these great scientific minds across the world and all the projects focused so desperately on figuring out what this is, it might not be long before we finally find this huge missing piece of the puzzle.
We need teams like Euclid. That's the only way you can get the data that you need. But to understand that data, to give it some interpretation, to give it an idea, could come from one person. That could be the next Einstein.
This weird creature might just be the best living explorer in the universe.
Took him into space, put him on a satellite, opened up the door, set him outside, exposed him to extreme temperatures, vacuum, right? Hot, cold.
Huge radiation.
And they come back alive.
This is the tardigrade, often called the water bear, and you can probably guess why. And they might even hold clues as to whether life on Earth arrived from outer space.
These creatures are the best candidates to explore whether life came from somewhere else in the universe or it emerged on Earth.
Could they even be the origin of life themselves? So what is a tardigrade? They're aquatic, microscopic animals, barely visible to the naked eye, as they're transparent and only about 1 millimeter long. They also love mossy conditions, which has earned tardigrades their adorable nickname, moss piglets. Aww.
Tardigrade means, its Latin name, slow stepper. Tardi means slow, and grade it refers to foot. You can start to see he's got long, thin filaments coming off his body, and some actual, more almost look like horns coming off his head that he uses in feeding.
So why are these moss piglets the ultimate space explorers? Well, despite being water-dwelling creatures, they have a special process of morphing or adapting to hostile surroundings, like radiation or freezing temperatures. By drying themselves out, they can cope with all kinds of nasty conditions.
As that sample jar starts to dry out, as that specimen starts to dry out, what's cool about these guys is they can survive that extreme desiccation, drying down to like a crispy little booger.
It's called a ton. They roll up into a special, tight ball, essentially, like a roly-poly bug almost, and then go through a series of radical chemical changes in the cells in their bodies to deal with this loss of water.
Being in a ton form, tardigrades are as far from alive as you can be. But give them a splash of water and they spring back to life. What better place to test the robustness of a ton-state tardigrade than the freezing sprawls of Antarctica?
We extracted them from soils in Antarctica, shipped them back here frozen solid, and they've been frozen solid here at least -60 since 2012. Holy moly! It's mind-blowing, dude. It's basically the same community that I saw when I collected them in Antarctica. We put them in a tube, froze them, shipped them. 4 or 5 years later, we want to study them, right? Pull them out, we thawed them out. And now, what I'm seeing now looks almost exactly like what I saw when I was looking at them, like fresh in Antarctica.
So they can survive the most extreme conditions on Earth. But what about in space? Byron and his colleague Carl took them on a special outing to the International Space Station.
Took them into space, put them on a satellite, opened up the door, set them outside, exposed them to extreme temperatures, vacuum, right? Hot, cold.
Huge radiation. And then when they brought them back to Earth, they did what you're seeing here. They dumped some water on them, see if they actually reanimate.
Voila. they take the water up, man, and they start, right? They swap it out the molecules, and like a machine, man. You add the water to it, they take them up, cells start to do their thing again, and they come back alive. It always blows my, look, I'm an old fat dude, and I've looked at these 100 times. Thousands of times, millions maybe.
You're not that
man,
old.
well, and then when I actually look at them under the microscope every single time, I'm like, dang, that's cool, man.
Just like that, the mighty water bear enters tun state and navigates brutal conditions that would kill almost every other living thing. So if we know they can survive in space, and we know they survive on Earth, could it be possible that these space explorers travelled between the two, possibly even sparking life on Earth? When the Israeli space agency Space IL crashed their lunar lander Bereshit in April 2019, one scientist began to wonder, could the colony of tardigrades they had on board have survived? And could they survive a crash landing to Earth if they hitched a ride on a meteorite? Alejandro Traspas Muina of the University of Kent set about replicating the Bereshit crash and the kinds of pressures that this little batch of bears would have experienced by firing them out of a gun. Okay, so not quite a gun like that, more of a lab-based gas gun. Alejandro recreated the moon's conditions in a chamber and then fired the tardigrades into sand to recreate the impact that they would have had on that fateful day.
Knowing how fast the spacecraft from the Bereshit mission crashed, we thought, well, let's try different speeds up to 1 kilometer per second, which, if you think about it, if just to get it into a daily activity, just think you're in your car and your car starts going faster and faster and faster, up to 3,600 kilometers per hour. So this is how fast tardigrades were shot. So we started with 0.5, which they all survive, 100% survival, so that's great. We researchers happy, tardigrades happy, and we kept going. We went up to 0.7, and they again survived. Then we went up to 0.9, and unfortunately at these speeds tardigrades couldn't make it, which means they didn't survive the Bereshit mission.
But this isn't the end of tardigrades in space. Alejandro's studies continue. She and her team are testing whether they could survive in the water plumes or the icy surfaces of the moons of Saturn and Jupiter.
These creatures are the best candidates to explore whether life came from somewhere else in the universe or it emerged on Earth. I do not believe life is unique to Earth.
So don't write off tardigrades just yet. They and other extremophiles could still provide the answer to the life we live today. The Earth is speeding up. It's literally spinning faster. Could it cause a tech meltdown? And what have melting glaciers got to do with it? You may or may not know, I wouldn't expect you to know, there are 86,160 seconds in a day. But scientists who measure time have found that in 2021, the average day is 0.05 milliseconds less than this. That's because the Earth is literally speeding up. Okay, so you might think 0.05 milliseconds, so what? But this actually goes against everything that we expect to see happen, and scientists are desperately trying to find an answer. Because since its creation, Earth's spin has actually been getting slower. In a not very recent history, the days on Earth used to be twice as fast. But what does a faster spinning Earth actually mean? 3.5 billion years ago, the planet's rotation used to be only 12 hours long. At that kind of pace, life would really suck. We'd have nightmarish weather patterns with hurricanes tearing across the land. Centrifugal force would pull water towards the equator, flooding entire regions like Indonesia and the northern tip of South America. Okay, that's a worst case scenario, and Earth is unlikely to ever spin that fast again. But if we keep speeding up, it could be bad in another way. By 2030, there could be a full-scale technological meltdown. GPS relies on precision timing, and if a day falls too far behind that 24-hour benchmark, there could be disastrous consequences. For one, satellites could lose their correct place in the atmosphere, and we'd lose all means of being able to predict where they are in the sky. If we leave this slip for too long without correcting it, then our navigation systems will be completely wrong, throwing all of our smart technology off course. Fortunately for us, we can sidestep this disaster, and there's a fairly easy workaround. Timekeepers can add and take away what's known as leap seconds to account for these tiny differences. They can alter what's known as international atomic time, which can be adjusted for the subtle discrepancies between the Earth's rotation and our clocks. And what's pretty mind-blowing is that by observing the night sky, we can keep track of these tiny changes. So keeping time is a pretty skilled art form. That's how we know that the Earth is spinning faster. But that doesn't explain why, despite billions of years of slowing down, the Earth's rotation is speeding up. So what's causing it? This is Dr. Jazz Hill-Valler. She's an expert in how the climate affects the Earth's rotation.
So we probably all know that the melting ice caps is going to cause sea levels to rise. Well, it's also causing the Earth to spin faster. And what happens when the Earth spins faster is that we get a greater centrifugal force. Imagine a figure skater. When you watch figure skaters, they start off spinning really slow with their arms out, and as they bring their arms in, they start to turn faster and faster. That's because they're bringing more mass towards the center of their rotation. So how can that happen on the Earth? Well, water has this crazy property where when it freezes, it actually expands. So if you think about all of the glaciers and the mountains and the ice sheets as being these huge, tall, towering sheets of ice, well, what would happen if we suddenly melted them really quickly, which is something that we're seeing happening at the moment? If we take all of that mass in those glaciers and those ice sheets and suddenly it melts and gets closer and closer to the surface, just like the figure skater bringing their arms in, all of that mass is going towards the center of rotation, meaning that the Earth is going to start spinning faster.
This meltwater currently sits at the poles. This is why right now scientists believe the Earth is spinning faster than usual. So will it get faster forever? Here's the conundrum. Actually, scientists expect this to be just a blip. Although it's been getting faster for the last 2 years, experts expect the Earth to go back to its longer-term pattern of slowing down. And it's the Moon that's causing this.
This is to do with the tidal relationship between the Moon and the Earth. We only see one face of the Moon. It's tidally locked with the Earth. So as the Earth is turning, the Moon is pulling the ocean towards it, and then as we move away, the oceans go back round, and that causes our tides. So this kind of wobbly dance between the Moon and the Earth means that the Moon is slowing down the Earth, and all that energy that's lost from the Earth slowing in its rotation is getting put into the Moon's orbit, and the Moon is actually moving further away.
As it continues to drift away, the effect of the Moon's gravity on Earth weakens, causing us in the longer term to slow down. What's more, over time, the melted water in the polar regions could actually make the Earth spin slower. Some scientists believe that the water will drift towards the equator, which will further slow down the Earth's rotation. This is called equatorial bulging. Think of it as a big spare tyre around the middle of the Earth. It exists already down to the centrifugal force exerted on the ocean by Earth's rotation. But adding to the weight of this tyre is no good thing.
All of that excess water is going to go and sit around the equator, which means that there's more mass further out from the centre of rotation. The equatorial bulge of water is going to get higher, which means that around the equator there's going to be even higher sea levels than we originally predicted. It could mean that hurricanes and typhoons and cyclones that form at the equator could become more severe because there's more water vapor there. So the increased severity of these storms because of the Earth spinning faster is probably only going to be a temporary effect. But that doesn't mean we shouldn't be worried about it, because more severe storms means that we're going to see more severe natural disasters happening all over the planet.
So although at first glance it doesn't seem that important that the Earth is spinning a bit faster, it really does matter, because it could be a big hint as to what else the climate crisis has in store.
Who owns Mars? It's a surprisingly big problem. With the USA and China planning to send humans by the 2030s, and with private company SpaceX potentially sending them by 2026, it's gonna get pretty crowded up there. You can even go online and buy a bit of Mars yourself. I've got mine. So who owns what up there? And what happens if things get nasty? I think we're gonna need a space lawyer.
It's time to explore the unexplored.
Space law sounds like a fantasy job, but it does kind of make sense. Surely there must be some kind of rules and regulations. Well, yes, and it started in 1957. The US and the Soviets are in the midst of a Cold War. They're sworn ideological enemies. Suddenly, the Soviets launch Sputnik, the first ever human activity in outer space. It flies around the Earth a few times, including directly over the US. And that raised a whole bunch of new questions. If an enemy vehicle enters your airspace, then you can shoot it down. But suddenly people had to think about, where does airspace end and space begin? The prospect of war in space was so frightening, they decided to keep the war on terra firma. To the surprise of the rest of the world, they joined together and drafted the Outer Space Treaty. Finally, it's over to the space lawyer.
The most fundamental baseline principle is found in Articles 1 and 2 combined, which basically makes outer space into a kind of a global commons, an international area, legally very similar to the high seas, and no single state can act as if outer space or part of the outer space or even part of the moon is part of the national territory. It's basically open for all states, and freedom for states to be active there is the bottom line. The drafters of the Outer Space Treaty were basically concerned with two elements, if you will. One was the military use of outer space, and at a secondary, subsidiary level about science. The treaty didn't really discuss things which we are confronted with today as questions, at least theoretically, like the settlement on the moon or human settlements on Mars.
So it's good that states are free to use space, even if they weren't thinking about settlement. But that wasn't the only thing they weren't thinking about in 1957. The treaty only refers to political states. It doesn't even mention private companies. So does that mean that the billionaires of the world are exempt from the treaty?
One of the clear drawbacks looking back at the Outer Space Treaty was the absence of any detailed reference to the private sector. So what you see in the Outer Space Treaty is only one almost fleeting reference to the private sector in the guise of what they call non-governmental entities. But at the same time, it made sure that the state, in this case the United States or any other state, where those activities belonged to, was the one being responsible. And then Article 7 followed that up with also liability. So not only you as the United States will be responsible for them, for whatever they do, and you will be liable for any damage they cause by doing that. So the United States cannot dodge any international responsibility just because SpaceX or Virgin Galactic or Blue Origin does something in outer space.
Okay, so I get that ultimately states are responsible for what private entities do in space, how they operate, and any damages. But what about the use of land on Mars? We're planning on building habitats and living on Mars. Is that even allowed?
So we have to make a very fundamental and important distinction between, on the one hand, the prohibition for any state to own part of Mars. On the other hand, the freedom of outer space activity, which is the other part of the global commons thing, also means the freedom of simply establishing a habitat, putting space objects there, which then serve as houses, or probably even excavate minerals locally and build a habitat from those minerals. That all is in principle, again, allowed. And of course, there is a tension between those two, because it is one thing to be allowed to land somewhere, to put people down somewhere, maybe to have them live there for 25 or 30 years. But at what point in time should we say, wait a minute, now we are moving to something which looks too much like a real colony, which is prohibited by the Outer Space Treaty? But again, that question has not been solved yet.
But it's not like here on Earth, where if you break a treaty, we can physically take action. Mars is over 300 million kilometers away. So if the USA or Russia or China or a private company starts breaking the rules up there, wouldn't it be pretty hard to stop them?
Next question is then, of course, what happens if a private entity disregards the international rules of space law? Well, if that happens, then of course the first line is that the operator who goes beyond the terms of the license will be held criminally liable under the laws of his own country. It becomes a little bit more complicated at the second level when we go to the international arena. Either these states have to agree to a tribunal, or they have to sort things out on a diplomatic level. And of course, then the reality of the international community kicks in, that the bigger you are as a state, the more you might get away with.
These are all crazy scenarios that could arise in the future. And talking of the future, many people see Mars as a future second home for humanity. But how would our laws on Earth work in space? And if no country is allowed to claim sovereignty over celestial bodies, then how will it be governed if there are communities and multiple generations of Martian people?
But of course, at some point in time, certainly when they start living there, knowing that they will never return to Earth, when they probably get babies there who have never been on Earth for any part of their life, there will be a tendency for those quote-unquote colonies, I prefer to use the word settlements actually, to say, well, we don't want to be ruled by this earthbound state anymore, because they have no idea what it means to live on Mars and to be safe on Mars. So we want to create our own legal regime, and sooner or later that may actually become, we want to create our own state. I often compare this with the Pilgrim Fathers who went to North America, and then after a number of years said, well, why are we still paying taxes to the British king in faraway London? So it took a war of independence before the United Kingdom finally accepted, okay, let them be on themselves, let them be their own state. I just hope that when that happens in space, we are more peaceful as terrestrial states in allowing those to go out on their own. But that's still decades away, if not much further.
If my first chat with a space lawyer has taught me anything, it is that there is still a lot of grey area in space law. If we want humans to play nice on Mars, then we're going to have to answer a lot of these unresolved questions. And if you're silly enough to have fallen for one of those bogus websites that claims that you can buy a piece of land on Mars, well,
the paper is just worth the paper it's written on, and it doesn't give you any title. Don't expect to reap any benefits from it.
the prospect of mining the moon is just around the corner. So what are they so excited about? Should we be doing it at all? How would it even work? Let's explore the unexplored. The moon is just a cold, empty rock with nothing of interest but a 50-year-old American flag stuck in the ground, right?
When we arrived there, almost a little bit more than 50 years ago, it's interesting to hear the recordings from the second man on the moon. When he stepped out of the lunar lander and looked around, he said, "This is magnificent desolation." But our view of the moon has changed radically since then, from magnificent desolation to a place that is full of important resources that we may use once we land there. Just to give you an idea of some of those, 45% of the moon is oxygen. It's just that it's tied to the rocks. These are oxidized rocks, but that can be heated and you can extract plenty of oxygen. It's got 21% of silicon for anything that we do with semiconductors, iron and titanium, very important elements. aluminum and calcium and magnesium and things like this, potassium and phosphorus. And also you find radioactive materials like uranium and thorium. Then there is the possibility of finding water. Water exists there, and that can be a total game changer, because water not only is good for humans, but mostly for propellant, because water, you can split it into hydrogen and oxygen, and it can serve as the most energetic propellant that we know.
This is incredibly exciting and really does demonstrate how there are more than enough resources to maintain a permanent base. We've got metals to develop technology and oxygen for breathing. We could use moon rock to 3D print habitats and extract hydrogen to fuel deeper space exploration, which could be a big game changer. But there are actually a couple of really exciting resources that in the future could make sense to bring back to Earth. The first is energy from light. Scientists are trying to look at how we can create solar factories on the moon. Now, the problem comes with how we transport that energy back to Earth, and one way is using microwaves. We could beam them through the atmosphere, through the clouds, and collect them in a receiver here on Earth, which could give us enough power to supply the entire world 24/7. This is still a long way off and doesn't make financial sense yet. But there is an element on the moon that we don't have much of here on Earth, one that could radically shake up the energy industry.
One of those elements is called helium-3. Helium-3 has been identified as a potential fuel for what's called fusion energy. Right now, the way that we obtain nuclear energy on Earth is by fission. You hit an atom, you split it, and in the process, you generate energy. Fusion is totally different. Here, you bring two elements, two particles, and you fuse them. And in the process of doing that, which requires a lot of energy, then a lot of energy is also released, and is released directly into electricity. You don't have to go through heating and then steam and then producing electricity. And even better, the residue is helium. Just helium, the one that, again, you can use for inflating balloons. So it's a non-radioactive waste that you can get out of that.
So it seems like mining the moon could not only serve us in space, but also provide helpful resources for us back here on Earth. But that's likely somewhere in the future. What about today? There is one resource that countries are especially interested in, and that's rare earth elements. The interest in rare earth elements has exploded because they are one of the main components of the communications industry. Neodymium is used in speakers, lanthanum in lighting, yttrium for computer screens, and gadolinium in X-rays. Despite being called rare earth, they're not actually that rare. The issue is that they're found in concentrated areas, which makes them a highly valuable bargaining chip for countries that have them within their borders. One of the countries that dominates the rare earth industry is China. Because of this, countries like the US are starting to ask questions like, well, what if China decides to restrict access to the US? Where can we get them from? The answer is, you guessed it, the moon! But would the US just be able to go up and take what they want? What are the laws for governing resources in space? The 1967 Outer Space Treaty states that no single country can claim ownership over any celestial body. But it said a little about mining. And because of this ambiguity, two schools of thought have developed as to how we interpret the treaty. And this has got space lawyers, yeah, space lawyers, debating the issue.
So far, the international discussion has centered around two major viewpoints. The one argues, since the moon belongs to everyone, it means that the resources in the moon's subsurface, whether it's water or iron or gold or platinum, belongs to everyone as well. And you can't allow a single state to say, okay, I'm going there, or I allow my private sector to go there and mine it for their own commercial profit. That's the one interpretation. The other interpretation says, well, it's a global commons, and just like the high seas, once you are there and you do something there, part of the freedom of the high seas / outer space, you can own it and sell it and make money with it. The comparison is then with the fish in the high seas. So these are the two opposing views. We still have no legal agreement amongst all the states that this is the appropriate interpretation. So we still have a ways to go before all the states are on the same page.
Because of this ambiguity, countries are now taking legal matters into their own hands. In 2015, the United States took the first step by saying that any company that sets up operations in the United States will have the right to access, extract, utilize, and even sell resources from the moon. Not own it, but the right to access and utilize it. The following year, Luxembourg became the first European country to establish a legal framework around space resources. After that, the United Arab Emirates joined in, and most recently in 2020, so did Japan. So you're seeing how these countries are moving independently while trying to abide by the United Nations Treaty, but while finding ways to extract resources. But even if we can mine the moon, should we?
That is a concern. Are we going to mine the moon so much that we're going to start changing the face that we see there? Are we extract so many resources that it may affect its orbit or its physical parameters? Some of those concerns are understandable, but some of them shouldn't be of much concern. But in terms of causing major damage on the moon, I think that that's not going to happen, at least in many decades or many centuries. But we should start planning ahead on how to do it so that it doesn't cause a problem in the long run.
So should we mine the moon? Well, if you have any interest in travelling to the moon or beyond, or potentially solving our energy crisis, then the answer may be yes, with the caveat that it's done legally and with no irreparable damage. Over the next few decades, the picture is going to start to get clearer as the moon gets busier and we find out exactly what is there and how much of it there is. When that happens, that's when things are going to get interesting. And hopefully we'll be able to find a way to share resources and avoid conflict here on Earth. So humans are going to Mars, and soon, lots of them. SpaceX could be going as soon as 2026, NASA and China by the 2030s, and India, Russia and the United Arab Emirates are all planning on it too. But what happens when they all get there? How can we actually survive? Well, some lucky scientists have already been there. Okay, not really. They're living in a Mars simulation right here on Earth to troubleshoot what could go catastrophically wrong when they do go to Mars. It's time to explore the unexplored. Okay, let's break this down into two key challenges we're going to need to overcome if we go to Mars: the physical and the psychological. Let's start with the physical. In many ways, Mars and Earth are quite alike. It has a similar dry land mass, volcanoes, craters, and its days are just 37 minutes longer than ours. What would you do with an extra 37 minutes? But that is where the similarities end, and it's the differences where the problems start. Gravity is just 38% of that on Earth. It means that you can jump higher, but you'll lose muscle mass. Imagine Dwayne "The Rock" Johnson training his chest every day with an 100-kilo bench press to maintain that impeccable physique. Suddenly, you land on Mars, and all that's available is a 38-kilo weight. Over time, his chest is going to get weaker and weaker. And it's a similar situation for astronauts going to Mars. Then there's the atmosphere, which is incredibly toxic. It's around 95% carbon dioxide. And to make matters worse, Mars is bombarded with radiation. And you get the idea. Mars is extremely dangerous. But luckily, there's a team of scientists who are actively trying to resolve these problems before we get there.
So when we talk about Mars simulations, what we're doing is we are trying to mimic the surface phase of a human robotic Mars mission. There's a million things that can go wrong. So when we think about Mars, we're talking about a world that is up to 380 million kilometers away from the Earth, which happens to be about 1,000 times the distance to the moon. And so it's probably 1,000 times more things that can go wrong. What we learned through our missions, it's not only the big things that are challenging, it's the small things. Think of being in the spacesuit. Despite the air condition, you start to sweat, but you cannot scratch your nose in the helmet, obviously. So little things like a little piece of foam where you can simply rub your nose into it and make sure you don't sneeze inside the helmet, which is a very bad idea, by the way, is a little thing that doesn't sound very glorious, but it's the things that make your work easier. And and really making sure that you have gone through the ins and outs of those little details can be a game changer. We have been doing those Mars simulations for 13 campaigns now, since almost 20 years now. And there's literally hundreds of experiments we did, and many of them went wrong or did not turn out the way like we expected them to do. And so we live and breathe the mantra of fail fast, fail cheap, and have a steep learning curve, because that's where you get better. We died many deaths, simulated, of course.
So gravity, atmosphere, and radiation are not actually the main concerns. These are the big things that we already know about, that we can create technology to help mitigate them. It's the small things that we don't know about yet. They are what could kill you, and there's a lot of them. So far, the answer to most of the physical challenges has been better technology and better spacesuits. But physical survival is only part of the battle. The team are also pioneering incredibly advanced psychological studies to figure out who will be the best humans to go to Mars.
We think that there's no such thing as a born astronaut. When we select analog astronauts for the Austrian Space Forum, this has been done very, very carefully. It's a multi-month process. We're evaluating, we just did a recent count from the last class, 637 individual parameters, anything from your cholesterol level to the length of your pinky finger and your ability to entertain little children and psychological factors and so on. You're much more looking for team players who are outstanding when it comes to health, but they also have technical competence, but at the same time who are also to display social warmth. They know how to tell a joke in the airlock at the right time. They know how to cook. They know how to do a magic trick. They can play the guitar. They can also settle down a broken leg or so. We are not looking into psychological clones of each other, but they need to complement each other. And so we're looking, actually from the anthropometric point of view, we're looking for the average Joe, the average Jane.
Or an average Josie?
So we have people who, in the beginning, who have a high technical competence, but then the work doesn't stop here, because you need to continuously monitoring the activities throughout the mission. That's exactly what we're doing with our simulations. For instance, we are in the previous experiment in 2018 in Oman, we had an artificial intelligence machine learning algorithm actually, who was looking into the pitch of the voices when people talk to each other. And we know when people are under stress, the average pitch shifts just slightly above the average. Or for this mission in Israel right now, we had one of the experiments, it was a fantastic experiment. The astronauts would have locators, so we could produce heat maps where the astronauts would congregate throughout the mission, or also relative heat maps, how much physical spacing they have in between them. If you don't like somebody, you tend to increase the distance, for instance. And so we're looking at the methods that tell us, here's a stressful situation emerging before the people would realize it, and magically then everything goes according to plan. And so it's about keeping them functional, by keeping them happy, by feeding them well, no food, no fight. But also making sure they don't smash each other's heads before leaving the lunar orbit.
So, with the right training, technological development, and people management, Dr. Gromer believes that we can definitely survive on Mars. But so far, we've only been focusing on a finite scientific mission. Go, survive for a bit, and then return. And that's understandable, given how many risks there are for even doing that. But this hasn't stopped people from dreaming even bigger. Elon Musk has famously said that we're going to Mars for good, to become a multi-planetary species. Some scientists have taken this and come up with some scary, speculative solutions to explain how we might survive. One of those is through mutations. The high levels of radiation on Mars could cause our bodies to change, and it's possible that some of these changes might actually help us survive. It's hard to predict how quickly this might take and the effects that it might have, but some scientists say that it could take just a few generations. Like, we could see changes in our skin tone to deal with the radiation. Could we go green? Our bone density might alter to account for the lack of gravity, and we might not even need our immune systems because we'll be living in such a sterile environment. But all of this is only relevant if we're actually going. Will we really ever be setting off to Mars for good?
Yes, we will. I can give you this in written. It's only a natural process. I think At the core of our beliefs and of our heart and our DNA, we are a migratory species. Our children and grandchildren will look up to the sky, to the moon, and see little dots of light out there on the lunar surface saying, we are out there. It's a statement to the universe. And the same will happen to Mars and the worlds beyond. It's just a matter of time.
Right now, the two Voyager spacecrafts are hurtling through interstellar space at 35,000 miles an hour. The space is so far away that it took 35 years to get there. And now we need new science to understand it.
I couldn't believe how nature was fooling us.
It made us rethink everything we knew about the shape of our solar system.
I think I discovered that the tail has a croissant shape.
And even where the edge of our solar system actually is.
There was a lot of confusion. Actually, the confusion lasted almost a year.
Even just to understand what Voyager is trying to say requires a very special set of skills.
It's really like a Swiss watchmaker. It needs to be a trained eye to tell me, can I trust this data or not?
What's even more extraordinary is how Voyager, the old spacecraft from 1977 with 64 kilobytes of memory, was able to make this journey at all.
3, 2, 1. We have ignition and we have liftoff.
Both Voyager 1 and Voyager 2 were launched in 1977, and it had to be then, thanks to an extremely rare planetary alignment that happens once every 175 years.
Where we could fly past Jupiter, get a gravity kick and go to Saturn, get a gravity kick and get to Uranus, and another gravity kick and go past Neptune.
Within just 2 years, Voyager 1 had reached Jupiter. Voyager showed us a planet, which looked so serene through a telescope, was actually rocked by hundreds of raging hurricanes, a glowing aurora at the North Pole, and 3 thin rings. Voyager took 33,000 images of Jupiter and its major moons that captured the world.
And we'd get to see these pictures and go, whoa, look at that, what's this, what's going on? It was fantastic.
On a night like tonight, our eyes, our minds, our souls, our blood are moving out through the universe. We're part of history, and that means that we have to replace the old myths with new ones.
Just 1 year later, and Voyager 1 had already sped past Saturn, spying intricate details in the planet's rings. From Earth, scientists could only see 5 or 6 of Saturn's rings. Voyager showed us that there were more than 100.
And I can remember those first pictures as we flew away, looking back at that system and seeing the reflected sunlight in that structured ring system was just so beautiful.
Then the Voyagers parted ways. Voyager 1 headed straight for the edge of our solar system. Voyager 2 took a more scenic route, reaching Uranus in 1986, and eventually Neptune in 1989, showing us yet more outstanding views of the green and blue planets, and spotted geysers on Neptune's large moon, Triton. And that was the main mission, the first human-made object to reach the distant worlds of our solar system. But the Voyagers weren't done yet. They were about to embark on the journey to search for the edge of our solar system. And before they left, there was one last thing to do.
Carl Sagan convinced NASA to turn the cameras towards Earth and take that very famous picture, the pale blue dot.
On that blue dot, that's where everyone you know and everyone you ever heard of and every human being who ever lived out their lives. It's a very small stage in a great cosmic arena.
These images were the last of 67,000 images taken by the two Voyager spacecrafts. Their cameras were then turned off to save power as they carried on their journey towards interstellar space, the boundary where our sun's solar wind ends and the rest of our universe begins. Problem was, nobody actually knew where it really was. Scientists thought that sooner or later, the charged particles that create solar wind were going to run out, and Voyager would enter a pristine environment of interstellar space.
We thought that would happen, maybe just beyond Neptune. But no, that didn't happen. Well, we said to NASA, give us a bit more money, another 5 years. Well, this kept happening year after year. NASA, please give us a little bit more money, a little bit longer, we'll be there.
As Voyagers 1 and 2 continued to move out into the outer reaches of the solar system, they remarkably continued to send very faint signals back to Earth.
And this is what makes it so interesting and so fragile. The whole instrumentation of Voyager was designed to visit the outer planets that have very strong magnetic fields. So now you're dealing with a signal that is almost at the noise of the instrument. And because Voyager was not designed for that, it's a miracle fit that all this team is able to go mine the data and pull out the signal and tell us what's going on.
Just 5 instruments were still operating on the spacecraft, and in 2012, more than 35 years since Voyager 1 left Earth, scientists started to see the first signs that they were crossing into interstellar space, through the boundary known as the heliopause.
Think about the heliopause as your walls of your house. This is what separates the environment that is dominated by the solar wind from environment that is dominated from other winds from other stars outside of our bubble, the heliosphere.
The expectation was that there would be a sudden shock, a burst of activity that would make it obvious we'd finally reached this sharp boundary. But the reality was much stranger. All of the detectors on Voyager were seeing particles suddenly appear, and then disappear, then appear and then disappear, and nobody had a clue why. These strange particles seemed to be coming from elsewhere in the galaxy.
Did we cross or not? The data was so confusing.
On one hand, Voyager was still being affected by the sun's magnetic field, but the particles were suggesting we had crossed.
It turns out what really tipped the scale in the team was the radio data.
The data was stored on the spacecraft using a tape recorder. So ancient technology, it's extraordinary. But it worked. And the data were gathered and sent back bit by bit.
And 6 months later, we turned to the radio station of Voyager, and guess what we heard?
These plasma waves, converted into sound that we can hear, were the final proof that we had crossed the boundary into interstellar space.
The first human-made object to venture into interstellar space.
Even more extraordinary than crossing the boundary into interstellar space was what the data said about the shape of the solar system.
I was tasked to create a computer model with all the physics that we know to kind of predict this shape of the heliosphere.
It turned out that the solar system's heliosphere is not round like you'd think, but has a tail from whizzing around the galaxy. And more than that,
I was finding that it has a croissant shape, 2 horns with a void in the middle. It was just a shock to realize that something such basic as the shape of our home is completely different.
And all of this was discovered by a small, extremely low-tech probe more than 10 billion miles away. And they're still going. In 2018, NASA's Voyager 2 spacecraft crossed the boundary. Finally, both Voyager spacecrafts, with their 1970s technology, had reached where no human-made object had ever been before: interstellar space.
There's very little material, very empty. Space can be very, very empty.
The environment out there is colder and denser. And of course, it's dark. There's not a lot of light. You're far away from the sun.
Voyager has also discovered that our solar system's impact is much bigger than we thought before.
We would have liked to get to a region where the heliosphere doesn't influence anymore the interstellar medium, what we call a pristine interstellar medium. What we're measuring now is a medium highly disturbed by the sun.
The Voyagers are still sending us ever fainter signals, still teaching us new things about interstellar space, but they're running out of time.
We probably have 2, 3, maybe 4 more years of power to communicate with Voyager.
But there are still so many mysteries left to be solved.
What is the environment outside? What's happening in the nearby stars that are influencing our system and so on?
So one of the beauties of the Voyager mission, that it started as a planetary mission, gave us the first images of our planets, discover volcanoes in the solar system, and then it went to discover our heliosphere, our vast, regions of our solar system, and enter into the galaxy.
Long after their power has gone, the Voyagers will continue to rush away from us, monuments to human endeavour and exploration, heading out towards the stars.
Voyager will continue its little journey in the interstellar space, way past when we maybe as a species will cease to exist, when we might move to a different planet.
It'll keep going and going and going and going and going forever.
Adam was part of a team researching exploding stars called supernova. Some of the brightest objects in the sky.
Our team had been experts in looking and studying nearby supernovae to measure essentially how fast the universe was expanding now, and so we wanted to be able to look out and see how fast it was expanding in the past.
To look back into the past, Adam and his team searched for supernova in the far reaches of the universe. And what they found there was barely believable. Edwin Hubble had thought that the expansion was actually slowing down, like dust settling after an explosion. And for almost a century, everyone else had thought he'd been right.
Decades of work, really going all the way back to Hubble, had shown that the universe was expanding, that the gravity of all the matter in the universe would tend to slow or pull back on the expansion after the Big Bang.
But Adam's research told a different story.
I was analyzing the first large tranche of data and looking at the supernovae to tell us how much the expansion was slowing down. And when I began looking at the results, they were really shocking. It wasn't slowing down a lot, and it wasn't slowing down a little. It was actually speeding up. It was as though the universe was currently accelerating, which was not on the menu of options at the time. When what you find is the opposite of what you expect, it's pretty shocking. I mean, mathematically, it's just a change in sign, but in terms of physics, it changes everything.
Adam believed that the expansion of the universe was, perplexingly, speeding up. And this was the discovery he'd emailed colleagues just days before getting married. By the day after, they'd responded.
Adam showed me fantastic plots before he left for his wedding. Who knows? This might be the right answer. I am worried. We all know that it is far too early to be reaching firm conclusions about that. You probably never will have another scientific result more exciting come your way in your lifetime. So there was a great deal of energy, excitement, and fear because, nobody wants to get something wrong.
But Adam wasn't wrong. The expansion of the universe isn't slowing down, as Edwin Hubble thought. It is accelerating. It's getting faster. This was an astounding discovery. And knowing how fast it was expanding meant Adam thought he could calculate when it all began.
So with new measurements, we found the universe that was about 13 plus or minus maybe 0.3 billion years old.
The vault is where we keep some of our most precious samples. Meteorites that have a particular scientific story to tell. I love all the meteorites, but I guess my super favorites are ones that formed right at the beginning of the solar system that can really tell us how the planets formed, because I think these are the most scientifically useful.
There are two main types of meteorite that land on Earth, and they're made of different materials.
Most of them come from asteroids, although some come from the moon, some come from Mars. But we have all asteroidal ones here. And among the asteroidal ones, most of them are made of rock. They've got rounded blobs in them called chondrules. They formed right at the beginning of our solar system. And a few meteorites are made mostly of iron. So this is an example of an iron meteorite that's really super heavy, too heavy to pick up. Around 1 in 20 are made mostly of iron. So they're among a rare type.
But where have these meteorites journeyed from? Most meteorites are debris, leftovers from the birth of the solar system 4.5 billion years ago. And most of them orbit the Sun between Jupiter and Mars in the asteroid belt.
Things in the asteroid belt can be quite chaotic. Often they crash into each other, or they can be affected by the gravity of Jupiter, which is the biggest planet in our solar system. And these things can make them career into the inner solar system and possibly crash down on Earth.
One February day in 2013, the sky above the Russian city of Chelyabinsk lit up.
Thousands of people saw this massive fireball which exploded in the sky. Over 1,000 people were injured, mostly by the shockwave of the blast when the bolide exploded. This was actually the biggest impact that we know of on Earth in the last 100 years. It was a really, really unusual event, and it resulted in about a ton of material ending up on the surface of the Earth.
In 1996, scientists announced they'd found evidence of possible Martian life. But Mars is a frozen desert planet. Its surface is completely uninhabitable. So could these strange shapes really be ancient alien fossils?
Release and liftoff.
And why do scientists think they might be able to find more of them?
I've always loved space. There's all kinds of things moving around, and we have no idea what's out there.
Planetary scientist Nina Lanza knows it can be difficult to interpret images from space.
This is Percival Lowell, who was an astronomer in the 1880s who was obsessed with Mars. He made many observations of the surface of Mars using telescopes on the ground on Earth.
Lowell's maps of Mars led to an idea that has enthralled us ever since.
What he thought he saw were these canal features. He thought he could see signs of a civilization on the surface of Mars. And these ideas had a huge impact, not just on science fiction, but also actual science.
So in 1964, when NASA's pioneering Mariner 4 probe reached the Red Planet, the public eagerly awaited their first look at the alien world.
Mariner 4 was the very first time we had close-up images of Mars from a spacecraft. People, when they first saw them, were incredibly disappointed because they looked nothing like the Mars of our imagination. There were no alien civilizations, there was no water, there were just a bunch of craters, and it really looked like the moon.
But just 7 years later, Mariner 9 made scientists think again. Its more powerful camera revealed something remarkable etched on the Martian surface.
This is an image from Mariner 9, and it's a really important image because it was the first time scientists saw evidence that there might be something more on the surface than just craters. This is a very sinuous channel that looks like it was carved by flowing water.
Each mission that followed has unearthed more evidence that Mars was not always a dry, frozen planet.
The Viking orbiter sent back some incredibly beautiful images, things like these flowing channels and teardrop islands, both of which suggest that water was once abundant on the surface and flowing, making these features. Mars Global Surveyor sent back this one, which shows a feature that looks like a beautiful river delta. The twin rovers Spirit and Opportunity found dramatic evidence. These are hematite spheres, and they form in water. This is a vein of a mineral called gypsum. So gypsum is a mineral that not only forms in water, but actually contains water in its structure.
It's now known that in the first 1 or 2 billion years of its life, Mars was much more like Earth. It had a thick atmosphere and was covered in rivers, lakes, and seas.
There is overwhelming evidence, just looking at the surface, that there was a lot of liquid water on Mars's surface in the past.
However, this discovery, while extraordinary, did not prove Mars also had life.
Life needs water, but that's only one thing that it needs. It also needs certain chemical ingredients and also environmental conditions before it can actually develop and thrive.
So this is sodium cyanide, highly toxic, but we use this material for our research for origin of life.
Cyanide is deadly. As little as 1/10 of a gram can be fatal. John's colleague, Zhenfeng Xu, has been working with it for over a decade.
Just keep gloves on. Don't eat it. That's for sure.
Mixing the cyanide isn't enough. It then has to be exposed to the conditions of early Earth.
I'm going to put this in the solar simulator. This machine just simulates the early Earth conditions.
Levels of UV light were much higher back then.
UV light is the energy to drive the reaction. And it's free energy from the sun. And we're going to use it.
Inside the machine, the cyanide combines and recombines, creating the building blocks of life.
After a few hours, we can detect amino acid, nucleoside precursor, lipid precursor. They're all very important biomolecules in life.
Cyanide may be the raw material needed to kickstart life. So finding an abundant supply is vital for John and Zhenfeng's theory. And one type of location is more promising than any other. Impact craters. As a meteorite strikes, its energy superheats the atmosphere, generating huge amounts of cyanide. And it also melts the planet's crust, creating hydrothermal systems.
The meteor impact is really important for life to start.
John and Zhenfeng's idea is that rainwater flowed down the crater walls, absorbing cyanide, and then was heated in hydrothermal pools at the bottom.
And reaction taking place then. So simple.
To prove their theory, John and Zhenfeng need evidence. Chemical traces from one of these craters.
On Earth, it's simply not possible to find evidence of these environments because all of the impact craters of that period have been erased by plate tectonics.
Scientists still don't understand how life began on Earth, but they do have 3 theories about how and where it might have happened. Hydrothermal vents with chemical energy for early life. Volcanic pools could have assembled cells, and impact craters could have provided the raw material for life. But here on Earth, essential clues to solve the mystery have long been erased. To find them, scientists need to return to Mars.